Hello math people, this is Mr. Ray with our next lesson in the quadratic unit. Uh, in the previous lesson we looked at the first method of factoring, and that was common factoring. Remember, common factoring, you're basically dividing out something that's common to all the terms that you're trying to factor. And common factoring is something you should try all the time. So it may work, it may not work, but it's always the first level of factoring that should be attempted. So today we're looking at the second method of factoring, and we call it quadratic expressions. Quadratic expression, remember, is a second degree polynomial. So it basically will look something like this: x squared plus bx plus c. B and c will be integers, could be negative also. So, but definitely the very first term will be x squared for sure. Okay, it doesn't necessarily have to have an x term or even a c term, but for this type of factoring, that will be most of the time it will have a value for b and c. And what we want to do when we factor, if you go look at this example, just the difference, what is factoring? Well, factoring is the opposite of expanding. So if we started with something like this, with brackets, when we expand, we multiply through the brackets and we get an expanded expression. No brackets anymore. X squared plus 3x is our result when we expand. Factoring is when we start with something that's been expanded, as in no brackets, and we turn it into factors, things that can be multiplied with each other to create the original expression that we start with. Okay, the good thing about anytime you see something in this form, now it's not always factorable, but if it is, that the factors, just let me write out the original part, the factors, and there'll always be two factors. Each factor will be binomial, meaning there's two terms. And if you think about it, if you want to create an x squared, the most basic way, and what you'll see here with this method all the time, is it's going to be x times x. So we're going to need an x term in each of the binomial factors, and all we need to do is figure out what numbers go here and here. And that's what this method is all about, figuring out the two numbers that when we multiply these two binomials using FOIL or matrix method, we'll get back to this expanded version here. Okay, so before I read this, I just want to show you kind of where this rule comes from. And sometimes understanding where it comes from makes it easier to learn the technique, or at least understand and memorize the technique. Okay, so what we have is, since we know we're looking for those two numbers, so what we're going to do is just temporarily call them R and S to figure out how they relate back to the original expression. So I'm going to write out the factors assuming we knew them. Okay, and these, like I said, R and S would be filled with actual integers, and the X would be X. It's not changing. Now, everybody, we know how to expand this. So I'm going to expand this right now. I'm going to use the Floral Technique. So remember, the X multiplies with the X, multiplies with the S, the R multiplies with the X and the S. So when I do that, first is X times X. So that's X squared. The outside is the X times S. Now we could put XS, but we know that S is really supposed to be a number. So I'm going to put the S acting like a coefficient. So even though it's X times S, I'm going to write it as SX. And then the next one is R times X, which I'll leave in that order because the R is like a coefficient. And then finally we get R times S. So I'll just write that as RS. So we've got our 4 terms. And if you think about it, here we actually have 2 x terms like we usually did when we expanded. So if we actually knew what the s and the r were, we could just add them together first. So I'll put them in alphabetical order here. R plus s times x. So it's almost like I did a little common factor here. I factored the x from both of these, and I got, so this would be the coefficient of x, okay, and this will be, since it's written as rs, this is the product of r and s. I'll just put that. Okay, so if I compare this back to the original question, okay, we said it was x squared plus bx plus c. So you can kind of see where these 2 magic numbers come from, the r and the s that we're looking for. So you can basically see that b will be the sum of the 2 numbers. So I'm looking for 2 numbers that add up to b, and c is the product of those same 2 numbers. So if we multiply r and s together, we get c. So what this tells us is if I was given, I'll just write this again, x squared plus bx plus c. Okay, so the 2 numbers we're looking for add, so the numbers add to b, and the same 2 numbers multiply to become c, multiply to c, the product is c, and the sum is b. Okay, so that's what we're going to use when we apply our technique. So I just wanted to show you where this comes from, and I basically kind of summarized it here. To factor a quadratic of the form x squared plus bx plus c, first find 2 integers, we call them r and s, whose product is c, and the c comes from there, and whose sum is b, which is the coefficient of the x term. Once these 2 integers are found, the factors of the quadratic are of x squared plus bx plus c are x plus r and x plus s in brackets. Okay. All right, and the cool thing about one of the cool things about when we find these 2 magic numbers is that there's only one possible combination. It's not like we won't ever find the same 2 numbers that multiply to c and also add to b. There'll never be 2 different pairs of numbers that satisfy that. So once we find that combination, that's it. Those are the 2 numbers we're looking for. Okay, and the other thing I want to note, not all of these x squared plus bx plus c are factorable. Okay, in fact, I can't just randomly start picking numbers for b and c and give them to you as questions, because if I did it just randomly, probably 90% of the questions that I randomly create would not be factorables. So I'm going to do one example in this lesson where it's not factorable, and you'll see why it's not factorable. But once you start getting homework questions and assignments or quiz or tests with these types of factoring, I'll tell you ahead of time, but I very rarely give you one where it's not factorable. So if you don't think it's factorable, it probably is. Okay, so now we're going to try this method out. I'm going to show you the technique. So we've got 5 on this page, and this is something I urge, again, practice, practice, practice. It's one thing watching me do it. It's another thing learning how to do it yourself. This is a good start, watching me do it, but until you practice it, you can't really suggest that you know how to do it. Okay, so here we have our first, we call this a simple trinomial. because it's got no coefficient visible in front of the x squared. So that's a sign that it will be using this technique. If you saw the number 2 in front, you wouldn't be using this technique, or 3, or whatever. It's got to start with x squared. Now, that being said, all the examples I'm doing today have x's as the variables, but I'm pretty sure in your homework you might see something where they just switch the variable up. Maybe that same type of question might be p squared plus 7p plus 12. The fact that we change the variable from x to p doesn't change the technique or how you factor. So just be flexible with the variable. It's not always going to be x. Okay, so as soon as I see this, I'm assuming it's factorable until I prove myself otherwise. So remember, we said as soon as you see one of these simple trinomials, you're going to get a head start on the factors. The factors are going to be 2 binomials, and the first term of each binomial is x. And we're looking for those 2 magic numbers. Okay, so remember the relationship between the 2 numbers we're looking for, and so I'm going to create a little t-chart. So we know the 2 numbers, first of all, the 2 numbers are going to multiply to 12. Okay, so I'm going to put, this is the way I do it, put a little multiply sign with a circle, just to not confuse it with an x. These 2 numbers multiply to 12, and they add to the coefficient, which is positive 7. I guess I should put a plus there, but we can assume that it is plus. I'll put a plus here. Okay, now what we're going to start with is the fact about what they multiply to, because there's only a really small number of pairs of numbers that multiply to 12, and we'll go through them in a second. If I started with list all the numbers that add to 7, well, you'd probably think of the obvious ones like 1 and 6 and 2 and 5 and 3 and 4. But what about 107 and negative 100? They add up to positive 7. So this actually has an infinite number of pairs of numbers that add to positive 7, whereas this is very limited. Okay, now we're going to list the factors of 12, and I'm going to be very methodical about this. I'm not just going to randomly put them down. I'm going to start with 1 and the number. Those are always factors. Okay, and then I'm just going to keep increasing this and ask myself, okay, the next one would be 2. Is 2 a factor of 12? Well, yes, it is. And its cofactor would be 6. Okay, now we keep going. What about 3? Yep, 3 is a factor, and it pairs up with 4. And if I kept going, I'd say, well, what about 4? Well, we already used 4 in the second column, so we're done. So there's only 3 pairs of factors that multiply to 12. Okay, I'm kind of ignoring the signs for now, but we'll talk about that in a future question in here. So now what I do is, okay, these are pairs of numbers that multiply to 12. Now what we're going to do, I'm going to add them together over here, and then just find the one that adds to positive 7. So these 2 add up to 13, these 2 add up to 8, and these 2 add up to 7. And I was looking for 7, and there's the combination that works. The 3 and the 4 are the mystery numbers we're looking for. They multiply to 12 and they add to 7. Okay, so once I know the numbers, I put them inside here as the second term in each factor. Okay, we did our first trinomial factoring. So it's basically going to be the same process every time you do this. And like I said before in the last lesson about common factoring, you can always check your work. Okay, if I took my factors that I just created, I think they're right. Okay, but I'm not 100% sure they're right, but I'm probably about 80% sure, but I want to be on a test, I want to be 100% sure. Okay, so if I do the FOIL here, it's x times x is x squared, x times positive 4 is 4x, 3 times x is plus 3x, 3 times 4 is 12, and when we add the two middle terms, because they're like terms, they both are x terms, that adds up to 7, and now I can go back and say, is that the same? Yes, it is. So that proves that my factoring is right. Now, if you do this check, sometimes I might ask you, but not very often. I just, might want to see, do you know how to check your answer? If you're doing this on a test or handing it in for marking, make sure you draw a line between your answer to the question and your check. Even better, you might put the word check beside this part, because now you're showing me, okay, here's my answer and here's the check of my answer. Okay, so you only need to do this on paper if I ask you, but again, it's highly recommended that you maybe do it mentally in your head. Just check that these factors create that expanded trinomial. Okay, so let's try the next question here. So what I'm going to do is, just like I did on this one, I know if it is factorable, I'm going to have two factors, binomial factors that both start with x, and I'm looking for these two numbers. So I'm going to do my t-chart. That's what I call it. You can call it whatever you like. And what do I know about these two numbers? Well, I know they multiply to 6. So I'll make my multiply to 6, and they add to 4. Okay, so again, I'm going to put the factors of 6, and it's really just 1 and 6 and 2 and 3. Those are the only two factors. So when I go to add these up, I get 7 and 5. But wait a minute, I was looking for 4. Okay, so the fact that I can't get two numbers that multiply to 6 and add to 4, okay, basically that tells me these two numbers don't exist that would create this. So if they don't exist, this is not factorable. So this is what I was saying earlier about I can't just randomly pick numbers to go there and there and expect it to work. In fact, most of the time it would not work. Okay, in this case it doesn't. Now I just want to put this example in here to show you when it doesn't work. Okay, the rest of the questions on here are factorable, and you'll be able to see that. And on the test, I don't think I would ever give you a question that's not factorable unless I warned you ahead of time. Sometimes I might say one of the 6 questions is not factorable, just so you didn't think that 4 or 5 of them were not factorable. Okay, so the rest of these are, and you'll see that when we do it. So for this one here, again, it's a simple trinomial. Simple because it's 1x squared, or just x squared. So I'm gonna write out where my factors are. Both binomials both start with x, and by doing that you feel pretty good because you feel like you're halfway done, even though you haven't really done anything. You just have to find those two numbers, and so we put our table in here. What are these two numbers? Well, we know they multiply to positive 28, and this time we actually have a negative. So this is where we're going to talk about the sign, okay, and do it in the most efficient method. The two numbers multiply to 28 positive and add to negative 29. Okay, so we'll just ignore that for a second. We're going to create our factors of 28 and then go back to this negative business. Okay, so if I'm looking for factors of 28, I always start with 1 and the number, and then work my way up on the left side. 2, does 2 work? Yes, it does. 2 goes with 14. And you can always be checked. If you're not good at your mental math, pull out a calculator, and for example, I don't remember, is 3 a factor of 28? So you do 28 divided by 3 and you get a decimal. So if you get a decimal when you try to divide a number into the whatever number you're looking at, that means it's not a factor. It'll be a factor if you divide it. For example, if I wasn't sure about 2 being a factor, 28 divided by 2 is 14. So not only, the fact that I got no decimal tells me it's factorable, and the answer is the other factor. Okay, so don't try too hard. That's what I'm saying. I don't mind you using a calculator, especially once we get to some higher numbers. It's sometimes hard to remember what the factors are. Sometimes you might forget, so use the calculator to your advantage. If I tried 3, for example, okay, to check if 3 is a factor, 28 divided by 3, I'm going to get something like 9 point whatever, and that tells me 3 doesn't work. So then I try 4. 4 does go into 28 7 times. Okay, 5 doesn't work. 5's an easy one because the number I'm checking would have to be ending with 5 or 0, and this is ending with 8. Then I try 6. 6 does not work, and then 7 we already did. Okay, so we're done. It's only three pairs of factors, at least positive factors. Okay, now here's not a lot of teachers go through this, so and even on the internet, on YouTube, I don't see a whole lot of teachers talking about the sign in a kind of a rational point of view where you're thinking your way through. So if I have 2 numbers that multiply to something positive, it doesn't matter that it's 28. If 2 numbers multiply and the answer is positive, that means it could be 2 things. Either both the numbers are positive or both the numbers are negative. Okay, so I keep that in my back of my mind. Then I go to this. The 2 numbers add to something that's negative. Okay, so what will the sign of these 2 numbers be? Well, they're either both positive or both negative. If they're both positive, they're going to add to something positive. If they're both negative, they're going to add to something negative. So that tells me that both factors have to be negative. That's the only way I can multiply them and get something positive and add them and get something negative. Okay, so now I'm going to I'll add these pairs up. I get negative 29 right away. Just to double check, I get negative 16, negative 11, and negative 29 was what I was looking for. So I can go back and put these numbers in. I have a -1 and a -28. And you can kind of check it in your head here. -1 times -28 gives me positive 28. The x's give me x squared. And then the 2 middle multiplications, I got negative 28x when I multiply these two, and negative 1x when I multiply these two. When I add those two together, I get negative 29. And you can see those numbers pop up here, negative 1 and negative 28. Okay, so that's how you think about the sign. Now, the 2 examples, or at least the 1 example that worked, sorry, go up here. Both of these were positive, right? So when I do my table, if both the signs are positive here, I know all the numbers are going to be positive. So I didn't really have to think about the negative numbers because, like I said, if they multiply to something positive and add to something positive, the 2 mystery numbers are both positive. Okay. So hopefully that makes sense. You can think logically through. I see a lot of things on YouTube where they'll try all the different combinations. They might try positive 1, positive 28, positive 2, positive 14, and you'll get like twice as many of these combinations, and half of them will be negative, half of them will be positive. But why waste your time? Just pick the ones that only create negative sums like these 3 do. Okay, so let's try this one here. X squared plus 3x minus 18. So let's build our brackets. Starts with x's. There's the 2 mystery numbers. Okay, here's our t-chart. You can know why it's called a t-chart because it looks like a t. And the first thing we know, they multiply the 2 mystery numbers, multiply to negative 18. and they add to positive 3. So this time I'm going to put both signs in to make it crystal clear. Okay, now like I said, when I do my factors, I'm not going to worry about negatives. I'm just going to work with 18. Okay, so when I do my factors, I get 1 and 18. Move down to 2. 2 works. It goes with 9. 3 also works. Goes with 6. 4 doesn't work. 5 doesn't work, and then we're back to 6. So we know those are the only 3 that work. Now, I didn't talk about the sign yet, so let's think about this. Okay, so the two numbers multiply to something negative. So the only way that can happen is if one number is positive and one number is negative. Okay, now some people would just stop with that and do all the combinations. So you'd have negative 1, 18, 1, negative 18, etc. You'd have actually 6 different pairs. But if I know that one's positive and one's negative, but they add to something positive, so what does that tell you about the bigger number of the pair? If they add to something positive, that means the bigger number has to be positive. Otherwise, if the bigger number was negative, when you add them together, you would get a negative sum. Okay, so this tells me small numbers negative and larger numbers positive. So the good thing about writing them factors in a nice orderly list like this, the numbers on the left are always the smaller numbers, the numbers on the right are the bigger numbers. So if I know the smaller number is negative, I just go down the left side and make those negative. And I know the bigger numbers are positive, so I just leave them the way they were. Okay, so now I'm going to add these together. So negative 1 plus 18, that's positive 17. I'll put the sign here. Negative 2 plus 9 is positive 7. And negative 3 plus 6 is positive 3. And we have a winner. It's this pair of negative 3 and positive 6. They multiply to negative 18 and they add to positive 3. It meets both conditions. And that's the only, like I said before, there's only going to be one pair of factors that satisfy both things. So once you find it, you know that's it. So now I put these two numbers into our blank spaces here. So the 6 is positive, so make sure you put a plus. And that's our answer there. Okay, so let's try one more. So again, we know this is a simple trinomial. It's got x squared plus or minus something x plus or minus a number. So let's build our little template here for our answer, like we've been doing every question. Build our t-chart. What do we know about these two numbers? Well, we know they multiply to that. So multiplies to negative 21. And they add to negative 4. So add to negative 4. So what are the factors of 21? Again, don't worry about the negative yet. Factors of 21, we have 1 and 21. 2 doesn't work. 3 works. 4 doesn't work. 5 doesn't work. 6 doesn't work. Okay, so we're back to 7, so we're done. Okay. Now, about the signs of these, because obviously if I multiplied 1 and 21, I get positive 21. So this can't be right, so let's fix it. Okay, the two numbers multiply to something negative, so that tells me you're going to have one of these numbers is positive, the other has to be negative. So we have a positive and a negative. When we add those two numbers together, we get something negative. So this time, it tells me that the bigger number is negative, because when I add them together, I'm going to get something negative. So the biggest of the two numbers is negative. So that's the numbers on the right side. So I didn't leave myself very much room here, but I'm going to squeeze in a negative sign in front of the second column numbers. So I have 1, negative 21. When I add those together, I get negative 20, and when I add these two together, positive 3 and negative 7, I get negative 4, and I was looking for negative 4, so there's our mystery numbers. So now I can just insert these. Remember, you have to put a plus sign if it's a positive number, and of course the minus sign if it's negative. Now, would it matter the order that I put these? Like if I put x minus 7, x plus 3? No, it would not matter. Because when you multiply two things together, it doesn't matter which order you multiply them. You can think of two numbers. Like when I multiply 2 and 3, it's the same as when I multiply 3. Well, 2 times 3 is the same as 3 times 2. So that works for these binomials as well. I usually just put them in the order they're listed here, but if you felt like it, you could put x minus 7, x plus 3, and it's full marks for that. Okay, and again, you could check your solutions every time you do this. Once you get good at it, it probably takes you about 5 seconds to check it in your head. So not a lot of wasted time for ensuring that you got full marks. Okay, last question here. This is a bit of a word problem, and on the test, for this unit, there will be one, similar type question with, like a factoring application question. I'd have to admit they're always a bit contrived. They're not the most interesting questions, but it's still important to be able to interpret the words back into the processes that we've learned. So let's see what this says, okay? Determine binomials that represent the dimensions of the rectangular water garden with an area of, in meters, of x squared plus 5x plus 6. So, one of the hints here is, well, there's what we just worked with. That's a simple trinomial. Now, it always helps to draw a picture. There's lots of visual things in here. So the first thing I'm going to do is draw my rectangular garden. It doesn't matter if it's totally correct, but it's a rectangle. So what have they told us about this? They've said that the area of this rectangular garden is represented by this. So inside, I'm going to put area equals x squared plus 5x plus 6. Okay, and there's a width and a length. I personally don't care which side you put these on, because you could always just turn the picture and it's the other way. So if you remember, area of a rectangle is length times width. So I'm just going to write this out again. Area equals length, and I'll put a dot for multiply. Now we already know the area is this. It's x squared plus 5x plus 6. Okay, and what we're trying to find is we want these binomials that represent the dimensions. So the dimensions are the length and the width. So we want expressions that represent that. So right now we don't know what they are. So I'm just going to put, and you have to leave enough room for two terms because they said binomials. So we're looking for two binomials that represent length and width, that when I multiply them together, I'm going to get the area, which is x squared plus 5x plus 6. Well, this is just like the questions we were doing. We're basically factoring this trinomial into two binomials, and one binomial will represent the length and the other will represent the width. Okay, so now, so we're looking, so remember what these numbers represent. This time I'm actually going to do it in my head, and I think you could too. I want two numbers that multiply to 6 and add to 5. So there's only two pairs of numbers that multiply to 6. That's 1 and 6, and 2 and 3. 1 and 6 doesn't work because that would have to be a 7. But 2 and 3 work. So 2 and 3 multiply to 6 and add to 5. So that tells me that the two numbers we're looking for are positive 2 and positive 3. So remember what these represented. This is the length and this is the width. Like I said, it doesn't matter which is which to me. So I'm going to put length equals x plus 2. And if I want to be really impressive, I'm going to put the units here. So remember, how do we know what the units are? Well, it didn't tell us what the length and width are, but it did tell us, oh, it does down here. The area in meters is, actually it'd be meters squared here. So it's telling us right here that the units for length and width are meters. So if I wanted to, I could put a little m there. And then for width, very similar, x plus 3 meters. Okay, now that they didn't tell us what x is, but then on the second line here it said, the second part, determine the dimensions of x represents 1 meter. So we basically we substitute in 1 every time we see x here. So that would be 1 plus 2 meters. So that's going to be 3 meters. And then this is going to be 1 plus 3 meters, which is total of 4 meters. So we know that the dimensions, that's probably good enough for the answer. So the dimensions, I'm just going to make it totally clear, would be 3 meters by 4 meters, and I'll just put in brackets here, if x is equal to 1. Okay, so this is kind of a not so subtly hidden factoring question, because it gave us the area, wanted to know what expressions could represent length and width. Okay, so that basically says I need two things that multiply to get this. So the only two things that multiply to get this would be two expressions, both start with x, and add two numbers, and so we figured out what those factors would be, and then use them to calculate the actual length and width. Okay, so like I said, you might see like one of these application questions to do with factoring, but factoring is most of the questions you're going to see when you're tested on the first unit are going to be, here's a bunch of factoring questions. Find the factors. Okay, so there's some questions down here from your textbook. So again, I really want you to try as many as you need to try to feel good about knowing how to do this. So if you see a question that's got, say, A through K type question, you might try the first couple, and if they're no problem, then maybe skip down, do the couple in the middle, and if they're no problem, then do the last two, because usually they start off easier than how they end. So if you really only want to do 4 out of the 10 parts, I would say do the last 4 to make sure you can do the toughest ones. Okay, so that's it for today, and we'll talk to you on the next type of factoring, which will be complex trinomials. So that will be, go back to the previous first page, where is it? Okay, so today we looked at factoring trinomials that look like this, and the next lesson we're going to add a wrinkle to this. Well, what if you had a number in front of the x squared, like a 3 or a 7 or a 2? So this technique only works if there's a 1 in front of here, x squared, and we're going to learn the technique to be able to factor other trinomials that have other coefficients besides 1 in front. Okay, so that's it for today, and we'll speak to you on the next lesson.